All right, guys, welcome back. Let's wait for a minute so that other people can come in. I think the last part, the third scenario whereby a linear system of equation has infinitely many solutions. When I was explaining it, my voice was breaking. A lot of people didn't hear me, so I would try to repeat it again and see. And then we will call it a day for today. So that you will have time to review what we have done today. So we have 16 students that logged in again. Now we have 17. So is it that everyone was not hearing what I was saying?
We had some part of it.
Okay.
I had some part of it, but it get to a point that it totally, your voice it was not even audible. I was not even hearing nothing, just seeing the pictures.
All right, so what I will do, I'll just go through everything again, the third scenario, whereby we have infinitely many solutions. So I think we have 18 students back. So let's look at the third scenario, then we can call it a day for today. The third scenario. So the third scenario is that, we are given a system of linear equation, and the solution there is infinitely. That is, when we say infinitely, we are saying that it can go and we can count as much as up to infinity. We should also be taking lectures. Some of these audios, the recording could be poor, and sometimes the light goes off and the recording will not be finished. So let's see this as a physical class. Let's be taking notes that can supplement the video if it's available. So let's look at this scenario. What I was trying to do normally is to build the intuition about a particular scenario before I even solution it. So let's say that let's assume that a system of, let's say, to solve this system, solve the system that is a simultaneous equation. So we have this system given to us, 2x minus y equals to 1. This is a linear equation, so we call it linear equation 1. So another equation is this 6x minus 3y equals to 3, which is also another linear equation. We have this. So they asked us to solve this. And we said to ourselves, we can use graphic or algebra to solve this. So for here, we will use substitution to solve this. And in substitution, all what we need to do, we make one equation. In this case, we take equation 1 and make y the subject of the formula to stand alone. So we will take this, which is 2x minus y equals to 1. So the goal here is to make y the subject of the formula, as I said before. So all what we need to do, we can transpose, this will be 2x. 1 will come here and the sign will change to minus 1 equals to, y will come here and the sign will be positive, which can equivalently be written as y equals to 2x minus 1. So we can call this as our equation 3. So all what we need to do, this equation 3, we substitute it in equation 2 as we did before, as we were doing throughout here. So we will substitute this into here. And if we do that, we will have 6x minus 3 times y. And we said y is what? 2x minus 1. So all what we need to do, we take the value of y, which is 2x minus 1, then equals to 3. So what we will have here, this will be 6x minus 6x plus 3. So 3 times 2x, it will give you minus 6x. So minus 3 times minus 1, that will give you 3, positive 3. Then we have equals to 3. So we solve this. So this will be 6x. This will be 6x. In fact, I will take step by step. Equals to 3 minus 3. This will come here, which is this minus 3, and the sign will change. So 6x minus 6x, this will give us 0. Equals to 3 minus 3 equals to 0. So we have an expression here. So what can you observe from this expression? One, there is no variable there, but the statement also is what? Is true. So if you are solving a system of equation and you come across this equation whereby there is no variable, you understand, and the left and the right side of the equation are both 0, then you can conclude that the solution, the system has infinitely many solutions. Has many solutions, meaning that the solution has many solutions. So you watch out for expression like this. So once you have this, then you can conclude that the system has infinitely many solutions. But even though you cannot list all the solution, but we want to know a few of them. So to know a few of them, what you will need to do, you can make best use of this. You understand? So we can say that this is the solution. So we can say that x is this, then y should be what? 2x minus 1. So when we can assume that x is here 1. So when x here is 1, so we substitute 1 here, that will give us what? 2 times 1, that will give us 2. Then 2 minus 1, it will be 1. This is a solution. We can equally say that also, we use this x, 2x minus 1. We can assume, so this one, I just pick it randomly. You can take any number. Because we said that the system has infinitely many solutions. So we can say, assume that x here is 2. So when x here is 2, we substitute that 2 into this, which is this one. So it will be 2 times 2, which will be 4. Then 4 minus 1, that will give us 3. This is another solution. So we can also say that x equals to 3. So when we say x equals to 3, that's 3, we substitute it here. So it will be 2 times 3, it will be 6, then 6 minus 1, that will be 5. So you can do this until you go to millions. So that's why we said the system has infinitely many solutions. But we can find some of those solutions. This one is a solution, this one is a solution, this one is a solution. And you can use 3, 4, 5, 1 million, 1 billion, you go on. But it's good sometimes you list 2 or 3 solutions, like this one, 1, 2, 3, that should be fine. So this is what we mean that the system has infinitely many solutions. So you can pick any number for x. It can be 1, 2, 3, 4, 5. So when you pick 3 for x, so that number you substitute it to equation 3, it will give you the value of y. So we have that. So how does the graph looks like? That is the geometric solution, the graphical solution. What we did here is just the algebraic solution. So how does the graph look like? So let's look at the graph, and from there, then I can take your questions, or if you have any comment to share with the class, we can do it. So we have the graph here. Y-axis. So we looked at it. All what we need to do first, we know the system. The system is what? 2x. Sorry, that is too big. So we have this. So the system is 2x minus y equals to 1. Then we have 6x minus 3y equals to 3. This was the system. And we want to graph this. And if we want to graph it, remember, what do? We find the intercepts. So let's look first for the first equation, 2x minus y equals to 1. So if we want to find the intercept, so for y-intercept, then x equals to 0. Then y is what? Minus 1. This is the y-intercept. So for x-intercept, when y equals to 0, x equals to what? Half, or 0.5. Those who like fractions. Yes.
Excuse me. You say when x is equals to 0, then y is equals to -1.
Yes.
That's -1. You know, I'm confused. The first session I was not there, so I don't know how you have the -1, and also when there's half. Can you please explain to me how you get those numbers?
You said you were not in you didn't attend the first class, right?
No.
Okay, so that's the the problem here, because that's why this class, they are integrated. It's prerequisite. Like today, those who didn't attend today's class, they might have a problem next class. So what you could do, these videos, the last class videos, I'm sorry for that. I should have uploaded it and shared with you people. So I will upload it and share the links with you people. Equally, what you could have also done, to get the notes from your classmate as well. So, but if I want to go back and try to explain intercept here, it will eat today's time. So what you can do is to get that video, and then I'm sure it's a very when you Google it, like X and Y intercept, it will tell you YouTube or anywhere. It's everywhere. But if I want to go back and explain that today's lecture, I will not be able to achieve it. And this trimester is very, very short. We have a lot to cover as well. So please go back and get that video. Then once you review it, then you will know how we are getting this intercept. Okay, so this is x-intercept for this equation. Okay. So then we can draw, so what we will do also, we have to find the intercept for this equation. That is 6x minus 3y equals to 3. So for the y-intercept, what we will have, this is when x equals to 0. So what we even mean by intercept is very simple. If you pay attention, like when x equals to 0 here, so what you will do, wherever you see x here, you substitute this 0 there and solve for y. Then you will have this answer minus 1. That's the meaning of intercept. So this is y-intercept. So for x-intercept here, we are saying that if y equals to 0, what will be the x here? So to do that, you substitute, we have y here, remove y here, and put 0 there. And if you do that, this expression will go off. So you solve for x. So when you solve for x, then you will have nothing but half. So this will be x-intercept. So remember, this situation, we are looking at infinitely many solutions. If you check here, the y-intercept here and y-intercept here are the same. Here, the y-intercept for this equation and the y-intercept for this equation are the same. If you check here also, the x-intercept here and the x-intercept here also are the same. So what is this telling you? It's telling you that these two equations, their graphs should be the same. That's just the meaning. So it is telling you that the x and y intercept for both these equations are the same. And it's because of that, That's why we have 0 equals to 0. So it's telling you that these two equations are the same. That is the mathematical interpretation. So all what we need to do, it makes our life easier. Instead of drawing two lines on a plane, we have only one. So here we'll go on and have our units: 1, 2, 3, 4, and 5. It goes on. So here we will have what? -1, -2, -3. I'm sorry, drawing graph with a mouse on computer is horrible. So we have y here. This will be 1. This will be 2. This will be 3. And this will be 4. As well, we go for the negative point for y. We have this 3 and then 4, and it goes on. So here we said that y-intercept is what? And when x is 0, y is -1. So here we said x-intercept, if y is 0 here, x is what? Half. So that will be around here. So if we do the same thing here also, we'll have the same point. So we'll have something, a graph. This is always a struggle for me. So let's see how best it will come out. We have this. So this graph or this line is representing both 2x minus y equals to 1, as well as it's also representing 6x minus 3y equals to 3. So this is the graphical solution. So you will see that in an infinitely many solution, the graph, you only have only one line representing the two linear equations. But when we come to, okay, that one is, when we come to no solution, we have two lines, but these two lines, they never meet. And two lines that never meet in mathematics, we call parallel lines, you understand? The first one, we have two lines, but they intersect at a unique position. Only one solution exists, which was 2 and 3. But here, we have infinitely many solutions, you understand? For example, like we have 1, 1 is a solution. This is a solution. So 1, 1 here, this is a solution. So we also have 2, 3 is a solution. So we have 2 and 3. We have 2 and 3 is a solution. And we also have what? 3 and 5. We also have 3 and 5 is a solution. So we have 3 and let's say 5 is here. And 4 is a solution. So it goes. So this will go until infinity. In mathematics, infinity, this is a sign for infinity. So we can choose as much as possible, 1, 2, 3, 4, 5, all will be a solution. That's why they call it unique. It has infinitely many solutions. Infinitely means there is no end in mathematics. There is no ending. So we can go both ways. We can even use minus, if it's -1, what all you need to do, you just substitute -1 here, then you'll have y values. So this is what we call a linear system of equation. And that brings us to the linear system of equation. We talked about the general form. We look at the specific form. We use both substitution and elimination method to solve it. And the solution can be unique, whereby we have only one point. And if you look at the graph, they intersect. And the solution, there might be no solution, whereby we have two parallel lines graphically that will never meet. The solution can also have infinitely many solutions, whereby we have only one line, like this one you are seeing. So we will stop here for today, and I will try to share some materials with you. You can read in details and the audios for this class and the last class as well. But let's be taking class note as well. Sometimes these audios, they can be very horrible, the recording. So this brings us to the end of today's lectures. If you have a comment, a question, the floor is open, please. let's make the class interesting. Let's be interactive, huh? Or maybe the explanation was perfect.
So when can we
Everything was understood, eh? Is everything understood?
Hello,
Yes, Mr. Yes.
Sanyang. How are you?
Okay, Mr. Sanyang, yeah, welcome.
It's not actually a question, but anyways, just a suggestion.
Good. That's
Since
good.
you know
Suggestion are welcome.
This is mathematics, and it involves a lot of practice.
That's right.
So I was suggesting, if you could give us more questions to practice on, maybe at least that could be better. At least we know the theoretical aspect so far.
Okay.
So we can apply that on the questions that you give us here.
Okay. That is noted, and I like to hear those guys. You will once we finish the chapter 1. I will give you an assignment that will, because I don't think there will be no. I'm not saying. I'm thinking. There will be no physical exam. So end of every chapter or part, then I will give you some assessments to do, and that will count towards your final grades. So, but with this, I will look for more exercise to give it to you. Even I don't mark them, but you can exercise as well. But there are also exercises whereby you have to submit it back for that will count to your final grade. So I'll look for those exercises. Thank you, Mr. Sane.
Okay, you're welcome, sir.
Mr. Ture?
Yeah.
When can we get to this video?
I will do my best today to upload it and then send the links to you by good grace today with the previous one last class.
Okay. Okay, thank you.
All right, you're welcome. So if there is no comment, and also I welcome suggestion that can make the quality of the lectures improve, because the goal is to make the quality improve each session. So let's share and interact as well. So for your guidance, next class we will be looking at let's say some applications of linear equation, especially linear system of equations. How can we use this in business world? Especially, I'm sure most of you have heard about demand and supply. How can we use this linear system of equation to solve some demand problems, shiftings of increase and decrease in demand? We also look at production issues as well. So next class will be application. Let's try to review this. Let's try to know how to find intercepts of linear equation. Is important. It will be so paramount. What we will be doing in the next class. You can always reach to your colleagues for help as well. We have tons of materials on the internet as well if you want. So please, intercepts, let's review it very well. They will be very, very important. What we will be doing in our next class. So if there is no question, no comment, then we can end the class here. And I wish you all a happy weekend and have a nice weekend. Oh, by the way, class rep, I hope you have taken the attendance.
Yes, I have.
All right, great. So have a nice weekend, all of you.